Let's do graph problems today from blind curated list series again. Okay, let's do this consecutive sequence. So given an unsorted array, find the length of the longest consecutive elements sequence your algorithm should run in of n complexity. So what we can do is so since 1 2 3 4 is longest increasing, this will all be increasing. So let's create a map and put all the elements in a map first. List of integer map dot put num. In num we'll simply put the same value num, right? And then what we can do is we can put a map of integer and boolean, and for every number we'll simply say if this is visited or not. Okay, false. So first it is not visited, so we'll simply make it false. So the idea is if we are at 3, we will search 1 and visit 1, and that's all we can go. And if we are 3, we'll also visit 2, right, in a loop, so that we'll know the longest sequence. So let's keep the longest sequence in max. For every int num in nums, what we can do is if map dot contains, let's say our int x is equals to num, right? If map dot contains key x, so let's do this like this: while map contains x, let's say 3, and this map dot get so when we are 3, let's go till 1, right? And while x minus 1, yeah, map dot get x is not is equals to, while this is not and this is not visited. Map is of boolean, so this 3 is not visited. Then what we'll do is x, so this number will simply decrease, right? Let's go downward. So let's say we have 3, now we'll decrease and find 2. It find it again, 1, it found it. So let's say whenever we are at 3, it searches 2 and 1, and then whenever it is, or we can do x minus 1 just to be safe. So whenever we are at 1, we'll see if it contains 0. No, then we stop here, right? Yeah. Also what we can do is, while this also we can yeah, while map dot contains key x plus 1 and map dot get x plus 1, let's say this is our num. Now when we are 3, we want to go to 4, so we'll simply make num plus plus, right? So our maximum will be math dot max of already existing max, or so from any point 4 is the farthest we can reach, so 4, and so 4 is the farthest, meaning num is the farthest we can reach, minus x is the lowest we can reach, and then plus 1 just to include itself. Return max. We can also put it like this: map dot put x minus 1 as false. This is visited, true. Num dot 1 is also true, and map dot put in this true. Map bucket is oh, map. Yeah, we could have simply done this also. Should be the same. Okay, fine. Clone graph. Okay. So given a reference of a node, its node is like this. For simplicity, okay, you must return a copy of given node as a reference of the clone. So we have this original node, we'll make a tip copy of it. Okay, yeah. So what we can do is, let's say we have this node, node n is equals to, let's say we are creating a new node, is equals to new node of node, and since these all should be new, so this will take value and its neighbors. So for the neighbors, let's just say, okay, new array list, right? So 1 will be 1, this will be a new instance now, and for all its adjacency values, we'll simply add those adjacency values to the same node, new node. So that means for every list of node neighbors, let's call it neighbors, for every neighbors of this node, node dot neighbors, neighbors, what we can do is, okay, this new node dot new node has a neighbor, so new node dot neighbors dot add this. So we can't simply add this neighbor for every node of neighbor. What we can do now is we can create a clone of the same node of clone of these remaining nodes, right? So that is neighbor. Now whenever we are here, it will try to create a new node of 1 again, so we'll simply introduce a cache map of node cache. Then what we can do is, if, or we can simply, since these values are I think unique, right? Yeah, node dot value is unique. Yeah, because how will we know which is 1 and 1? So yeah, so what we can do, instead of node, we can simply keep integer. So if cache dot contains key node dot value, then we can simply return this cache dot get node dot value. Else, after adding all, what we'll do is cache dot put node dot value new node, and we can return new node. Should be fine. So okay, new hash map. Oopsie, time limit exceeded. So for every neighbors we are cloning the graph, and if that is found, where did it okay, let's see. We are creating a new node of this node and add a list. So we have, which is a node, and for every node of this node dot neighbors, cache dot put cache dot put, right, new node. Yeah, where is it now? Okay, if node is equals to null, return null. Okay, number of island, given a 2D grid of land and water, count the number of island. An island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. Okay, and you may assume all four edges of the grid are surrounded by water. So if it is water, count the number of islands. So this will make all this filled as water, and it will be 1. And here we have 1 water, 2 water, and 3 water, right? I mean 3 islands. So what we'll do, as soon as we find one, we make all these things as visited, or simply change the values of this. That way we'll know, okay, how many ones are there. So basically what we'll do is, for we'll traverse through this graph. Is it m times n or no? If grid is 1, then plus plus return count. So as soon as this 1 is found, that means at least there is 1 water island, will increase the count. Similarly, it's found here, will increase the count. So as soon as this is found, we'll surround all these other its next elements to we'll change it, right? Let's make it 0. Okay, surround water for this grid from position I, J. From this position, surround it with water, ij. Yeah, that's it, right? So what we'll do, public void surround water for this character grid from int, this is row, and int column. So what we'll do is, okay, if surround, or if grid I j equals to 0, then we'll simply return. That's what we'll do, surround water. If it is not 0, then we'll surround these values, this grid, with 1, right? So what we'll make is grid ij is equals to 1. Let's make this, and then we'll surround with at I plus 1 j. We can go always, so I minus 1 I j plus 1 I j minus 1. And now while we are doing like this, we have to check if is valid ij in this grid. If it is not valid, then return false. So that means we need to create another one. So public boolean is valid this path, int row, int column, int character array of grid. So what we'll do, return if this row is less than or equals to 0, or if row is greater than or equals to 0 and row is less than or equals to row dot length minus 1, and so row dot length is grid dot length minus 1, and column is greater than or equals to 0, and column is less than or equals to column dot length, that is column is grid 0 dot length minus 1. So we are inside the boundary of the grid, so we are not exceeding here, here, or anywhere. So it will be within the boundary, and after that what we'll do is we'll also check if this grid of row and column is 1, right? That's what we're checking. If none of these conditions satisfy, then we will simply return not false. But yeah, this should do it. Let's see, compilation error, ij and grid, there is no ij there. So row and columns, row is I, column is j. Okay, Stack Overflow. So as soon as we find it, we'll make it 0. Okay, let's test with this condition. Okay, cool. This is also done. Course schedule. There are total number of num courses you have to take, level from 0 to courses n-1. Some courses have the prerequisite. For example, to take course 0, you have to first take course 1, which is expressed at 0, 1. Okay, so to take course 0, you must take course 1. So 0 will, so you have to take 1, only then you can only after 1 you can get 0. And then there are this many courses. Okay, so int total course is our, of course, our num of courses, right? So let's just name it total course. Oops. Total courses, And then what we can do is so what we'll do if so is it possible to finish all the course? Here it's not possible, because to take 1 you have to take 0, and to take 0 you have to take 1 again. So this is a cycle, right? Basically, yeah. So what we can do is we can order it topologically, and then we can find the parent of each, and then do it. Let's do this. Okay, int array uh, in degrees. So how many in degrees are there? So in 0, uh, in 1, 0 case. So to take 1 there is nothing, right? So so how many courses are there? There are this many courses, right? New int of in degrees. So for all these courses, for int array of prerequisites and prerequisites, what we'll do is, if you see here, so you to take for example, to take course 0 you have to take 1, so that is represented like this. To take course 0 you have to take course 1, so 0 has a in degree of 1, and it is represented by 0. So that means in degree of prerequisite, that is the array first element, is plus plus, right? Because you need to take these prerequisites. So in this case, yeah, in degrees of not 0 but 1. So in this case it is, how is it? So to take course 1, you should have finished course 0. Okay, that means prerequisite 0, right? Yeah. So we need to take one course to study this first course. So in degrees will be, in this case there are two courses, 0 and 1, and the count will be, we need to take at least one course to study course 1, right? So now what we'll do is, okay, let's create the queue to find out how many courses has 0 in degree, what courses we can take, right? So queue is equals to new linked list. Then for every I equals to 0 till I less than this degrees dot length, which is the total number of courses. We'll put if in degree I equals to 0, then we can simply put this in queue dot add. We can add this. We can add this I, that is, we can take this course, right? Yeah. Then what we'll do is, okay, we can take this course which is 0, then we can traverse. Okay, while queue is not empty, let's look through all the queues, and you can see that, okay, int, so this queue is of integer type, hold int val is equals to let's just point it like this, queue dot poll, right? So at this point we got 0. So now what we'll do is, okay, all the links associated to 0 is 1, so let's go through prerequisites again. So for every prerequisites, if this value, because there can be many, if this value what we can do is, yeah, if this prerequisite, So what should it be? So the q dot pole will be 0, and this 0 is here, right? So 1. If prerequisite 1 is equals to our current value, then what we'll do? We'll do in degree of prerequisite. Uh, so this 1 will decrease, right? It is 0 minus minus. So as soon as this is found and used, we'll remove this, so and then decrease the value to 0. So now 1 will have 0 incoming in degrees. And what we'll do, if the in degree of this 1 is 0, if this turns out to be 0, then we can simply add this value to a q dot add prerequisite 0, right? Yeah, prerequisite 0. And once this is all done, we'll check if in all our in degrees uh, is everything 0 or not. So if so, for every integer in degree in degrees, if this in degree is not equals to 0, then you can simply return false. That means so based on our ordering, the graph should have been empty, right? I can so basically what we did was, we have a 0 here and a node 1. This can lead to node 2, which can go to 3, like this, right? One point here, and this can, so to take 2 also you might be have to take 0. So at first, since this had 0 in degrees, let's say it is like this also. So the in degrees of 1 is 1, the in degrees of 2 is 2 incomings, right? 2 incomings, and for 3 also 2. So in this, what we did is, okay, we added this 0 in a queue, and as soon as we processed, we find all the values linked to it. Yeah, we'll cancel this, decrease the value, so this 1 will become a 0 now, and 2 will become 1, because this is also removed and this is also removed. So now the next 0 is 1, so from 0 we'll evaluate, we'll cut this, decrease the value to 0, decrease its value to 1, and now next time this 2 is 0, so we'll cut this value and we can read this 3. So that means all the values in this in degrees should be 0. Only then we can say that it is we took all the courses. Return true else. Let's look for some compile issues. There is none. Okay, cool. Now graph valid tree. Oops, we don't have the valid tree. Subscribe to unlock. Let's do this graph valid tree now from the same list. Given n nodes from 0 till n, the list of undirected edges, each edge make a pair of nodes. Write a function to check whether these edges make up a valid tree. Okay, so for a valid tree to be valid, we should not have a cycle, right? So basically here, if you see, 0 goes to 1, and so 0 goes to 1, goes to 2, goes to 3. These are all from 0, right? these are all from 0, and from 1 it goes to 4. Similarly here we can actually run a topological sort, or we can also use union find to do this. 0 1 1 2, then from 2 to 3, then from 1 to 3, 1 goes to 3, 3, and 1 goes to 2, and 2 goes to 3, 3 again. So that means and then 1 to 2, 2 to 3, and then there is 1 2 3. So basically if you see, we have a 0, we have 0 to 1, 0 to 1 to 2, 2 to 3, and 3 to 1 again. So here is a cycle, right? This all go here, so this is not a tree. Okay, so for that what we can do is you can use union find. So let's just create that union find class. Let's say we have class disjoint set or union find, whatever you name it. Just implementing it, you can also use the same template for disjoint set, just the union find function. So what we'll do is we'll create a constructor disjoint set of int n, int array of set disjoint set is equal to int array of size n, right? And then arrays dot fill will fill all these values with -1. So we can write public int find int a if a set of a is less than or equals to 0 or less than 0, then we'll simply return the same a. Else let's use path compression, right? Else return set of a is equals to find of a. So this way everything, so the find of a, we don't point to just the one above it. So if it's like 1 2 3 4 5, directly we can say okay 0 to 5. We don't need to go from 0 to 2 to 3 to 4. So hence this, right? Now let's do a boolean public union union of int a and int b will be if, let's say we have a is equals to find of, simply put find of a if both the parents are same. Like here in this scenario the parent of 1 was 0, right? 1 was 0, and also the parent, so the 3's parent was 2. So at first we made okay 0 parent to 1, then we'll say okay 2's parent will be also 1, then 2 parent will be, sorry, 1 parent is 0, right? And then 2's parent is 1, which is now 0, and 3's parent is 2, which is also 0. Now whenever we are combining these 1 and 3, we simply find that okay both are going to the same root. So that means these are this is cyclic. So if a and let's consider b is equals to find of b, if both of these values are equal, that means we can't do a union of these two, so we'll simply return false. So let's make this function boolean, and then if this set of a is equals to set of b, if both are equal, then simply do a minus minus. If set of a is less than or equals to set of b, what we'll do is if both are equal, we can simply say okay set of b points to a, else set of A points to B, and we can return true, just forming this. Now what we can do is we can create this disjoint set union find this is a new disjoint set of this size n, right? So for every integer array is what we'll do, so for all these numbers we will simply union, right? Union find dot union okay, if the union of these two edz is 0 and edz, if the union can't be made, that is 1 and 3 here, right? Then yeah, whenever we try to union these two, we'll simply return if cannot win union. If this is false, then we'll simply return false, else this will just do the union for this is 0 and is 1. And at last, now to be a valid tree, since everything must include the number of vertex and number of edges should be the same, right? I mean -1. So we can simply say if this n, the number of vertex 0 1 2 3 4 is equals to edges dot length -1, there should be n -1 edges, right? Oops, null pointer on line 74 is valid tree line 7. Where is disjoint set of size n, then set is this, then union find that this stack overflow find. Oh, if set of A is less than 0, else find set of A, right? Oops, false. If A is equals to n -1 should be the edges length, right? Yeah.
Hey guys, let's do this alien dictionary. So here what it says is there is a new alien language which uses Latin alphabet. However, the order among letters are unknown to you. You receive a list of non-empty words from the dictionary where words are sorted lexicographically by the rules of this new language. Derive the order of the letters in this language. So if we see this example, we have W and then we have E. So since E and W comes before R, that's why we have WE and then R, and then uh, uh, T is followed by R. So we have T. So how is, if the order is invalid, return it. There may be multiple valid orders, return any one of them. So these words are sorted lexicographically. Oh, so yeah, so W and E comes after. So what we can do is, let's create a graph of every word as a node, and then let's see the link on how they are related. So for that, let's create graph is equals to new graph, right? And in this graph, what we'll do is graph dot add nodes for all these words, right? So let's create a class uh, class graph, and then what we can do is, okay, graph, just a constructor. And so in the graph what we can do is, let's initialize a map which is our graph, that is character, and this will have all the other mappings. So the graph, its vertices linked to this character is a set of other characters, right? So this is our actual graph. So graph is equals to new hash map of character and set of character, right? Now whenever we do add nodes, let's do this, public void add nodes from this string of words, right? So for every string word in words, and for every character uh, character of these words, so we are referring to WRT at first and then WRF. Now it's just W. So what we'll do is, if this graph contains this node, graph dot contains key, or we can simply do graph dot put if absent. If this character is absent, then we'll put new hash set, right? So we need to initialize what all it refers to. Then if it is already present, then graph, then that's fine. If it is absent, then we'll put. So these are just all the nodes. Now once the nodes are created, what we can do is add edges to it, add edges for these words, right? So let's just do this, graph.add edges. So right now what we have is, in our map we have W R R T F F E R, right? So these are all the words that we have. Now we want to check, now we want to add edges where all these W go to, right? So let's just add is public void add edges for this string array of words. Again, so for this what we'll do, for every
so here what we have is, so this W, so E comes after W, and since these are sorted lexicographically, so these words are sorted. Okay, so yeah, W comes before E, right? You receive a list of non-empty words from the dictionary where words are sorted lexicographically by the rules of the derive the letter. So here also Z, yeah. So basically now what we need to do is, for every string word in words, right? Or later, let's do it like this: for int I equals to 0 till I less than words dot length, right, plus plus, right? So what we'll do, since W is here and then comes the R, or basically in that sense, so W and then what comes next is E. right? So what we'll do is, and then comes R, since they are sorted, right? So WER, and only after R, if you see here, comes T and F, right? Only after R there is a T and then F. So that is how it will be. So just for that, what we'll do is, okay, let's start from 1, so that we will have what the first character is and what the second character is. So let's say our int first is equals to uh, words at uh, I minus 1, and int second is equals to word uh, I, words of I, right? And then what we'll do is, since if you see there is a difference in the length, and we need to make all this, so let's just say, okay, for every, for int I equals to, not I, but let's say equals to 0 to say less than math dot minimum of these lengths, first dot length comma second dot length. What we'll do is plus plus j. So now we have this and this. So for every characters, int first car is uh, first dot character at index j, and similarly second is, this is just to understand, easier to understand what is happening. Okay, this, and second character is second dot caret j, right? And what we'll do is, okay, unify these two, unify first char and second char. So that means, so we need to make an s between these two, right? So let's just have public void union character a and character p. So what this union will do is, so since this is the next value of w, we'll have map graph dot get this character a dot add b in a hash set, right? But add it only if this is true. That means if character b is already present, then we don't need it. Also what we need is, since we need to return this in lexicographic order, I mean the order whatever comes first. So let's introduce the in degrees. We'll do a topological sort, so that's why let's say, okay, and since these are all lower case letters, we'll do int array of in degrees. Here in degrees of array in degrees is equals to new int array of 26, right? Yeah. And now if let's say this was possible to add this new value, I mean the w can refer to r and it can refer to r again, so basically we can just, this will return false one, this will return false if it is already there. So if this new node can be added, only then we'll say in degree of this character b minus 97 will be plus plus, right? Will increase the in degree of e. So now this e, that is the in degrees, it will be on the fourth index, and it will be 1 now based on this, right? Based on this and this. So 97 is the ASCII number, so or we can better do a also. so that it falls to is both are the same thing. So this A means 97. So we did the union of all this. So that means it is fine till now. Now what we'll do is, okay, graph dot get sort, graph dot sort topological sort, right? And this will give us a string s, which will return s. Now all we need to do is do a topological sort. So let's just create this. Now this is similar to what we did earlier. Topological sort, public string topological sort. Let's create it here. So now string builder equals to new string builder, and then q is equals to new length. We have already seen a topological sort in previous examples, right? So this should be fine. So now what I'll do is for int I equals to 0 till I less than 26 plus plus, if in degrees I equals to 0, then we can simply add it in a queue. Q dot add this I, right? So what we'll do is in this in degrees arrays dot fill this in degrees with -1, right? Yeah. So now we have all this. We created the graph. We have this thing. We have the in degrees, and now we are doing the topological sort. Yeah. So now what we'll do is while this queue is empty, when this queue is not empty, simply return to a string int I is equals to q dot port. So our string builder dot append character of I plus 97, right? So we want to put this character ABC since I is only the indices. So, and now what we'll do is, so like this again, we already have that. Let's do the drawing. So let's say we have this node again, 1 points to 2, which points to 3, 4. So these are all ABCDs. Just think of this as A, B, C, and D. So now as soon as this A is found, we will decrease this 2, right? So for that, since we already, our hash map already has this, so what we'll do for not here, so set s is equals to our map, our graph dot get this node, which is I plus 97. So let's just put character c is equals to . This 97, and we put C here, C here, character dot get this character. So now for every character C in this set, right? Set is set. In this set, what we'll do is we'll simply decrease in degree of this C minus 97 minus, and if this equals to 0, right? If this is 0, then we'll simply add it to a queue. Q dot add so minus 17, right? This way we are breaking the loop, and then we are adding a new one, and we're simply doing it. Everything will be minus, so that is fine. Yeah, now everything is there. Let's look at this. So our Q is of type integer. Character C is already defined. Character CH. Set is a set of character. Where is the word? Line 52. Word to character array. Words I-1. String can be converted to strings. String. Name of first char and second char. This is character. This is character. Right? Okay, this is not the correct answer because F comes before. So if you look at this WRTF, ERT, why did F come first? Let's put some other examples like G and X and G, X and G. Wow. Okay. Looks like we are missing something. We are only written one when these are. Oh, we are not adding our first characters at this thing, right? We are not. So if you see, we are not adding Z. That means if you look at the is, we started from, we unified first and second. Yeah, we'll only union them if first char isn't is equals to, we don't want to go A to A, right? If first char is not equals to second char, only then union them. Right? Now at least we have this. Okay, now the f is gone. uh, as soon as these characters are not found, these characters are simply found here, then we can simply break this condition. We don't need to look for every characters, because we can't put R and T because R comes after E, so we need to maintain that order. So let's just break it. Now mm, so here let's not fill this with -1 because we are missing W. So let's do this, and we can check uh, during our sorting whether uh, so if in degree I, if our graph dot contains character I plus 97, if it contains this, only then and this is 0, right? Only then we'll do. Similarly, even here we'll add to a queue only if, but that's all fine. Graph contains key, right? So I think this should be fine. Let's see. Oops, so here it's the wrong answer. Let's just see what's the okay. So this failed here. Let's look at, so what is happening is we added, for this case we added ABC and AB. Okay, so ABC came here, and so let's check this. For int I equals to 0 to I less than 26 I plus plus, if our graph that contains this node, right? If our graph that contains this node, that is character I plus 97, and if it contains it and this in degree of and in degree of I is not equal to 0, right? Then we will simply return this. In degrees, still the wrong answer. Okay, and if this is not equal to 0, that means let's what is happening in ABC is Okay, for such situation, what we can do is, so in ABC and ABC, let's just do this. If words 0 to length is equals to words 1 length, and words 1 starts with word 0 starts with 4, word 1 false. Okay, this we can do. Okay, then add this condition there. This is because we are not able to form this graph. Okay. Let's do this number of connected components in an undirected graph. This was also in premium. This was hidden for non-premium users. So let's do this. Here the problem is if we are given 0 to n minus 1 and a list of undirected edges, write a function to find the number of connected components in an undirected graph. So here if you see, so this is also the same thing, right? Like we did earlier, we'll create a disjoint set, will you use union find and just unify all these. Okay, 0 has 1, 1 has 2, similarly 3 has 4, and based on how many connections are there, we can actually find uh, the number of different number of connected components. So there are 2 connected components, right? Here, since everything is connected, it's just 1. Okay, so let's do that. This join set, this is similar to the one that I did earlier. we can simply pull this from here, right? Let's just put it here so that we have the disjoint set. Now what we'll do is we'll create an instance of it, disjoint set. Let's call it union find. Of size n. So now what we can do is, so we created this disjoint set. So for every edges that we have, int array of is in edges, what we can do is, let's try to connect all this, unify all this. If these are unified, that means it is 0 union find dot union of is 0 and is 1, right? If these two are unified, 0 1 and 1 2, so if these two are unified, then we can simply do n minus minus, because now this connection, there is one connection, so that we'll know how many connections are there, right? Because if everything unites to 1, there will be n minus 1 edges, that is 4 edges, and this. Now if it separates out, then this will form a different one. So here, if you do n minus minus, this unifies with 0 minus 1, this unifies with this 2 edges, and then at last there will be only 3 edges. And there is, since this is decreasing, I mean there is no edge between 2 and 4, so it won't enter this union find again. So that's how we will decrease the count. Then I think we can simply return this n, because it is already so the number of edges, we are simply counting how many edges are there. So if we decrease the number of, I mean if there is a union between two, that means we are creating that many edges. So this is like, right now if there are 3 edges, the n will be decreased by 3, and the total number will be the whole 5 minus 3 edges, that will be 2. So simply decreasing it will give us the result, right? Yeah, that is also fine. Thanks guys. Pacific Atlantic water flow. So given m into n matrix of non-negative integers representing the height of each unit cell in a continent, the Pacific Ocean touches the left and top edges of the matrix, and the Atlantic Ocean touches the right bottom. Here, water can flow in 4 directions: up, down, left, right, to another cell, from a cell to another of equal height or lower. So from this cell to flow to this cell, if the value is higher than the previous, then we'll simply return false, right? So this can flow here. Find the list of grid coordinates where water can flow to both Pacific and Atlantic. So we need to find a place from where it can flow to both the Pacific and Atlantic Oceans. So for that, let's see, for int I equals to 0 till I less than where? Less than matrix dot length I plus plus, right? List of integer result equals new array list. Just putting the result first, we'll simply return this result. And for int j, it's 0 to say less than matrix 0 dot length j plus plus. What we will do is, if let's say if this can reach Pacific, if this value can reach Pacific, right, and can reach Atlantic, from where? From this IJ ij in this given matrix. From this ij in this given matrix. So if from this point, from any point, if it can reach either this and this, the order of return list doesn't matter. Both m and n are less than 150. Okay, so that means what we'll do, we can look through all and simply add, okay, result dot add this new list, or we can simply do list 10. Let's do this. List dot as list int array of ij. So let's do this. Now what we'll do, we'll simply see if this can reach here or not. So for that, let's create this. Let's create. So since at some point this is a sub problem, right? We did in previous things also. So if at any given point, so from 2, we don't want to, if we reached here, we want to know if this point reaches Atlantic and Pacific. We'll already have computed, we don't want to compute it twice. So let's just cache it. So let's just say our int array boolean, let's put it boolean. So at any given point we'll check if it is already if the next place, or if that item is already visited, right? Or boolean array of can reach Pacific Ocean. Pacific is equals to new boolean array of int m is equals to matrix dot length, and int n is equals to matrix 0 dot length, new boolean of m and n. Similarly, let's create it for Pacific. Can this point reach Pacific Atlantic? Right? Boolean of m and n. So now for any point, if it can reach this and can reach Pacific, this thing can reach Pacific and reach Atlantic, this ij, right? We have this boolean array. Just some formatting. Okay, now at any given point we are simply checking if this point can reach Atlantic and Pacific, this ij, and on while we are going through the Pacific, if this point can reach Pacific, we also have a boolean set which will see if this point or the next point was already visited, and if that point can reach the Pacific, then we'll simply cast the result to know if this point can reach Pacific or not, so that we don't have to compute it again. It's simply dp. Okay, now write this method, public boolean can reach Pacific from int row, int j, int array of matrix, and then int so our current value, let's just pass the current value also, matrix of ij. We don't need this, but also yeah, we can grab it ourselves, so we don't need this. Matrix, and then boolean can reach Pacific. Right, and this is boolean array, double array. can say is we can simply say it as int because we don't know, it might not reach also, right? So let's put it int, and what we will do is int int. So for every int array specific in Cambridge specific arrays dot fill. So what we'll do, if it is not visited, we'll put -1. If it is visited, and then 0, and else we'll put simply 1. Okay, so let's just do that. Arrays dot fill is specific with -1. Never did this before, never visited these places. So now on Atlantic we will do Atlantic -1. So now there's Cambridge specific and double array. Yeah. Now what we'll do, if this row, now since specific is here, so if row is less than 0 or column is less than or equals to 0, not equals to but less than 0, then we say, okay, we can simply say return true because some value reached here, right? Also, if this can reach specific at row and column, if can reach specific at row and column is either, if this is not equals to -1, then we can simply say return can reach specific is equals to 1. If this is 1, then true, else otherwise false. Also, this, if this row goes on the right towards Atlantic, we don't want to compute it, is greater than or equals to matrix dot length, or column is greater than or equals to matrix 0 dot length, then we can simply say return false, right? If this goes beyond this value, and also so matrix at this row and column is greater than, is less than the value that is required to pass through, then also will return false. Basically, water cannot flow if the value with one height equal or lower, right? So if we are at 2, let's pass in the value also. Matrix in value is matrix of I and J. Same goes for Atlantic also. Matrix I and J, and yeah, here int value, right? Yeah, and if this matrix at this, or even if it is lower, then if matrix Ij is less than, is greater than value, right? That means it cannot go past it. So let's say we are at 2, then it can't go here because this matrix row Ij is greater than our current value. Then we return false. Yeah, this. Otherwise, we simply return true, right? So boolean can reach is equals to, let's just do can reach specific with row plus 1, column and matrix at this row and column and value now is, since it reads till here, right, value will be matrix of row and column, which I already passed, and then this will be simply our own matrix, matrix, and then our val will be val, and can reach specific. Can it reach specific? So this will be it, is equal to this, or this, or this, or this, row plus 1, row minus 1, row minus 1, and column plus 1 and column minus 1. Right, we travel through all this part. So once this is done, we can simply put can reach specific at this row and column as this can reach can reach can reach can reach, then 1 else 0, right, and then simply return can reach. Now what about the place already visited? So for that, let's also create a visited boolean array of visited specific and visited Atlantic is this will be boolean, this will also be boolean. Let's just pass this. So can reach specific was int actually. This is boolean array of visited paths. Now even here, if this visited also contains this row and column, if that has already been visited, then we don't want to visit it again, right? But that will already hold by this, because this one has it, but we want to avoid going through it. Okay, this is just our cache, so we put here. But if we say for this point, if visited this row, so on this search we want to visit, if visited row column, then so let's just think about it. If we are here, if this has already been visited, then so from any point, at any given point, if it is already visited, then our can reach specific will already hold whether it has been visited or not, and then do it. So from this point, okay, let's say we're traversing from this point, and from this point, okay, can it reach or not is what we have, and then from this one, visited or not. So from here to here, it is, from IJ it cannot reach here. So on the right side, it cannot visit Atlantic. Pacific it can visit because it goes up, but we just want to know at this point if this had already been visited, and we don't want to go back to the same place again. So just for that we have this, but that also means that if this place was already visited, do we want to visit it again? We don't want to. So I don't think this is useful also. So let's just remove it, right? Let's just remove it for now. Let's just run our code. We don't have the other method, which is going towards Atlantic, can reach Atlantic, can reach Atlantic. So now can reach Atlantic will be can reach Atlantic, Atlantic, and Atlantic is at this place. If this are this, then true. Else if this, then return false. So on line 30 we have an error. What happened here? Okay, you can reach Pacific line 43. There is an error because we visited the same place again and again. Let's just break it, okay? Let's just put it. Let's just put this visited, comma. We visited. So we will simply say if visited this row and column and return false. We'll have the same thing here also. Visited, and then we'll make this visited equals to true. Right. Let's make the same here. Yeah, this is because if you see here, this is updated at the very last, so we will need it actually. So now Pero kami ganito eh. Listen to that.
What's up, motherfuckers? What's up?
Visited this row column is at the line, but we didn't found. What is this? Visited Pacific 922. Visited matrix IJ. So we have IJ matrix. We need a matrix. Matrix here. Matrix here. And then, oh, we already have a matrix. Matrix. Right. So once we already have a matrix, what we are passing is this, and then we pass the value, then we pass Cambridge Pacific and Atlantic. Atlantic and Cambridge Pacific. And then Boolean. This is array. Okay, Cambridge Pacific. This also need our visited. Visited, visited, visited. Okay, looks like we got it. Okay, array index out of bound for this. So we can simply say if matrix dot length is equals to 0 or matrix 0 dot length is equals to 0, return this result. Failed for this case. So what we missed here is 1020 10. Oh, we missed 1 2. Where did we miss 1 and 2? 2 is the 1 2. Okay, let's look at this. 1 2. One two should be able to reach. Should be able to reach. How do I enlarge this? So 1 2 is from this. From this point, can we reach? So here it failed. This is written true. So 1 2 is not found, but we just say that okay, let's reach this point, if this is already visited, if only we can find this and return true. Yeah. Yeah. Okay. Cool. Thank you.